Today we want to go into a little bit more detail about and do a little bit of practice in drawing the graphs of some sinusoidal functions. The practice that we're getting here, the information that we're getting is not just specific to trig, but it's a very convenient place to locate this information in your mathematical career, because these sinusoidal functions are so predictable. They have definite vertical parts and definite horizontal parts. So it's a very convenient time to introduce these concepts. So we're going to use sinusoidal functions to talk about graphs of functions in general. All right, so today I've given you 6 functions, and I want you to identify the amplitude, the period, and the start. Remember, start is local terminology because the functions go on forever in both directions, so they don't really have a start. But the way we're thinking about it is we're thinking about the sine of theta starting at the middle going up, then to the top, then to the middle going down, then to the bottom, then back to the middle going up. So we're thinking of that middle going up as a starting point. And so that's where we could start and end a cycle. For cosine, we think of cosine as starting at the top. So from the top to the middle going down, to the bottom to the middle going up, back to the top is one cycle of cosine. We're just giving those points names for convenience. It doesn't actually start there. We're just calling it a place to start. But the graphs go on forever in both directions. So once you identify those 3 things, the amplitude, the period, and the start, we want to draw the graph using our proper technique, where we draw the middle points, the top and the bottom points, all evenly spaced about, and putting our halfway points a third off the middle. Last time it was 30 degrees off the middle on either side, but now the period has changed. So instead of a 30 degrees, we're going to make it a third of the way between the named points off of the middle. So that little middle section looks like a line, and then we have the peaks and valleys above and below. So here are 6 functions that we can learn to read, that we're going to practice reading on. And here is our default sine and our default cosine. Our default amplitude is equal to 1, and our default period is equal to 360. Let's remind ourselves of what we do with these coefficients. The coefficient of the trig function, the number on the outside of the trig function, and the coefficient of theta, the number on the inside of the trig function. So if I look at the function y equals a times the sine of b times theta, notice that I've just modified this with multiplication. A is multiplication outside the trig function. B is multiplication inside the trig function. The amplitude is the coefficient on the outside. We just take our default amplitude A, or default amplitude 1, and multiply it by A. So that multiplication on the outside is going to stretch the graph vertically. So our changes in the amplitude is going to be a vertical stretch. If A is bigger than 1, like it was in these, because I forgot to include like 0.5, but missed opportunity. That multiplication after the trig function is going to make a vertical stretch if it's bigger than 1, or a squish if it's less than 1. Stretch or a squish. Notice that with what we do with the coefficient of theta, That is the number we multiply inside the trig function. We take the 360, the default period, and we divide by that coefficient. We don't multiply by the coefficient like we did the amplitude. We do the opposite. We divide by that coefficient. Not the opposite, I should say the inverse. We do the inverse. So this number B does produce a stretch or a squish, but this one is horizontal. These are the things that we want to notice. The operation that I'm using is multiplication. A times the sine of B times theta. A and B are both being included with multiplication. A is producing a horizontal, A is producing a vertical stretch or squish, and B is producing a horizontal squish or stretch. The other thing that could happen is that we could be multiplying by a -1. So specifically, I care about having an A be negative. So that will determine where our start is. If the number on the outside, if A is positive, then we start at our normal default places. The sign starts at the middle going up if A is positive, and the cosine starts at the top if A is positive. But if A is negative, we flip that over. We reflect the entire graph vertically. We're producing a vertical reflection when we multiply by -1. So if A is negative, sine starts at the middle going down. If A is negative, cosine starts at the bottom. All these modifications are modifications using multiplication. All modifications using multiplication. And we're producing stretches or squishes, or in the case of multiplying by a negative, a reflection. Depending on where we multiply, we produce a vertical change or a horizontal change. Any questions? How's everybody okay? All right. Let's take a look at some of these graphs, the things that we want to identify, and then practice drawing some nice sinusoidal graphs. So our first function is a modification of sine of theta. I've got f of theta is 3 sine of 2 theta. I'm going to post this later if you're missing any pieces. So problem 1. F of theta is 3 sine of 2 theta. So what is the amplitude of our function here? What's the amplitude? 3. Whatever number is being multiplied by the trig function is multiplied by the trig, multiplied on the outside. That's our amplitude. It should be the absolute value of 3, but the absolute value of 3 is 3. So the absolute value of 3 is just 3. Remember, amplitude is the distance from the middle to the top and from the middle to the bottom. Since it's a distance, we just use the value. We don't say the distance is negative. our default period is 360. But there's a 2 in front of the theta. So what's the period going to be for 3 sine of 2 theta? 180. 360 divided by 2 is 180. And where are we going to start this graph? It's sine and the coefficient is positive. So where are we going to start? The middle, going up. Now we're going to do what will look like cheating, because I want to draw a sine and I want to start at the middle, go up, then down, then up again. I want the vertical, or I want the amplitude to be 3, and I want the period to be 180. So I'm going to practice drawing a nice sine. So here's going to be my 0. And then I'm going to make sure that 1, 2, 3 points, 3 dots later, I'm at the top. Make sure I could split that in half. Then 1, 2, 3 dots later, I'll be at the middle again. Then 1, 2, 3 dots later, we'll be at the bottom. So leave a half, then down. Then 1, 2, 3 dots, I'll be back at the middle. I start by putting the horizontal easily divided into thirds each quadrant, and then vertical easily divided in half. Sine starts at the middle, going up, then to the top, to the middle going down, to the bottom, back to the middle going up. Next, I'm going to want to get my halfway points, and I go 1/3 of the way off middle to get halfway. Here's another middle, 1/3 before, and 1/3 after will be halfway. Here's another middle, 1/3 before will be halfway. And that's how we put a bend on our sine. Now all we have to do is make sure that when we hit our peaks and valleys, we're nice and flat at the top. Just kind of draw a little flat and then draw on your valleys and your peaks. The middle sections, we can almost connect with lines. Mine got a little bit bumpy here. So I draw a thicker line, make it more sketchy. I don't know if that's what you're supposed to do, like when you're learning to draw, but that's kind of what I do. Cover up any bumpy parts with a thicker line. Now you'll notice that we didn't label anything. How do we know how big it is? Well, we're about to tell our reader how big it is. So the middle is going to be at 0, and then the top is going to be at +3, and the bottom will be at -3. Now I have labeled the amplitude. Also, we want to label the period. We know that this starts off at 0, and we know that this ends at 180. So 0, 0, and 180, 0. There's my start and my end of one cycle. The rest of it is just divided in 4. Halfway, we're at the middle. So half of 180 is 90. So here at this point, we're at 90, 0. And then it's just halfway between these. A quarter of the period is halfway between 0 and 90, or 45. That's when we hit the top. And then halfway between 90 and 180 is at 135. So we're just going to take that period of 180, cut it in half, then mark the 1/4 mark and the 3/4 mark. Any questions? So vertically, once we label the start, then we'll have one cycle over here at 180. Then the other points that we care about are going to be a 1/2 the period, a 1/4 of the period, and 3/4 of the period. Quarter, 2/4, 3/4, 4/4, 0/4. So I guess my point is draw a nice cycle first, label it afterwards. How's everybody okay? Everybody looks a little bit stunned. Because you're a little bit stunned, or because it's a math class in the afternoon. It's difficult to say because we all have different kind of optimum performance times. So like, this is kind of past it for me. For a long time, most of my classes have been over at 1. So I have a long history of kind of being over at 1. So when I have to go past 1, then it's very iffy. This class starts at 1, which is the iffy time for me anyway. 8 o'clock is also pretty iffy, but that might just because it's first thing. So if I have an 8 o'clock class, then 9 o'clock class generally goes kind of smoothly. I use the 8 o'clock class to warm up. Then 9 o'clock class goes fine. I can run a normal 11 o'clock class. That one comes out pretty good as well. We go into lunch and then I should be done for the day. But now I've got like too much afternoon. You know what I mean? Some of you are going to be different. Some of you are like, oh, morning. No, I'm not going to be at peak performance time until the afternoon. Morning, it takes me all morning to get going. But once I hit like noon, from lunch on till 4, that's peak performance time, and all your best work happens then. And yet we still just have schedules like this. Do you know what I mean? It's weird. There are certain things that we know that we just totally ignore. Like there's a really strong argument to be made that by having high school students, kind of specifically high school students, teenagers, show up for work at 7 to 8 in the morning is incredibly damaging. Not just that they don't do well, it's actually damaging. It creates long-term damage. And then yet, what do? Well, schools always start at 8. Let's just keep starting at 8. So our argument is like, well, we've always done it this way, and it would be difficult to change, but we're just going to have to keep causing harm to all those teenagers. Do you know what I mean? And we're like, oh, well, we've always done it this way. We've always done it this way is a shit argument for doing anything. If we're going to play the we've always done it this way game, then that takes a lot of stuff that we should have off the table. Like, well, we've never let women vote before. Why should we start now? Oh, hang on a minute. That's not a good plan. You know what I mean? This old way is doing harm. Let's fix it. Anyway, what are we talking about? Oh, yeah. Change the start time. That's all we would have to do. High school doesn't start at 8 o'clock anymore. High school starts at 10. Most research suggests that 10 o'clock is a good time for teenagers to start. Teenager sleep cycle is different than child sleep cycle. It's different than adult sleep cycle. Let's use that knowledge to benefit people. High school starts at 10. Every other argument against that, why that's inconvenient, is just an argument for changing that too. Parents be like, but my job starts at 8 o'clock. I have to be there at 8 o'clock. I can't wait till 10. It's like, well, then let's move your job start till 10. Or if your best performance hours are at 8 o'clock, you start your job at 8 o'clock, and we'll find a way to get the kid to school at 10 o'clock. I don't see why these are such insurmountable problems. You know what I mean? Actually, I do. I see exactly why these are insurmountable problems. That's a lie. It's because we would have to spend money to fix it. And this is not an aspect of society on which we want to spend money. You know what I mean? I can tell that we like to say that education is important, but we don't really believe that education is important. You know, I can tell we don't believe education is important because we don't spend money on it. And we like to say that shit a lot. Oh, teaching is such an important profession. No one believes that. You know how I can tell? Teachers regularly starve. They don't make enough money to live in the communities they serve. Now, I mean, I do, but I don't have kids. And I'm married well, so there's that. Also, this is a better paying teaching position than, say, my friend living in San Carlos, teaching elementary school. You know what I mean? Don't be saying that education is important and then not spend the money on it. Anyone who is a veteran knows that we like to say, oh, we really care about our veterans. I know a lot of veterans who like look at that statement and say, I don't think that's true. You know what I mean? Anyway. It's fine if we don't care about education. If that's the decision that we want to make as a society, then that's fine. Just stop saying that you care and not spending money. Just say, we don't care. We just need the poors to work in the factories and do the jobs that are essential. But, you know, I mean, they're the poors, right? Just fucking do that. You know what I mean? Anyway. I think I'm privy to too many conversations that are really annoying. I've told you my plan that I want to pay you. I want this to be your job, right? I don't want you to have to do another job unless you want to. If you're like, oh, student is fine. I'll take the money for student. I'll make sure my work gets done, but I'm going to have another job because I want more than what student provides. Student provides me like my housing and stuff like that, but I want more, so I'm going to do something else. I'm going to get a part-time job and I'm going to do 1.5. If that's your personal decision, that's fine. But you don't get to make that for everybody else. All these motherfuckers walking around said, oh, when I was a student, I was going to school full-time. I was working 4 full-time jobs. I only slept 4 hours a week. It's like, well, listen, asshole, do you want that for everybody? Do you really think that's the standard that we should hold every single person to? Because not everybody can do that. I mean, kudos to you that, you know, you can disrespect yourself so much that you'll just prostrate yourself before the altar of money. Fine, but that should be your choice. Do you know what I mean? Anyway. Makes me angry because people are mad that we're forgiving student loans. Like the whole structure is still in place. It's still a scam to get people to go into debt. That's still working. But imagine, think about the debt that you have. Take 20 grand of it and just erase it. Think if that changes your life. Some people, that would be life changing. You know what I mean? Here's what's going to happen. Y'all are going to get through school somehow. You're going to make improvements to your life. You're going to get the job, get the house. You're going to be making six figures. It's going to cost you a lot. Not in money, but in time and effort and blood and sweat and stress. And you're going to suffer for it. Then later on, you're going to turn around and decide that that suffering should be inflicted upon your children. If not your children, then someone else's children. And if you only care about your children and not someone else's children, then we as a society have failed you badly. If the only reason to get you to care about another human being is to make that human being related to you, then fuck off. We don't need that. Do you know what I mean? Anyway. I just get really angry when people say, well, I want to make sure students have skin in the game. That's why it needs to cost money. It's like, well, listen, motherfucker, we're asking people to spend a full time's worth of time for 4 years. The single most valuable resource that you have, your time and attention. I want 4 years of it. Fuck the money. That's the demand. That's big. Does that make sense? You can't get that shit back. You can make more money. You can't get that shit back. Anyway. All I ever hear is these talking points. The students need to have skin in the game. I want to make sure that they're committed. If they show up, they're committed. Every time you charge someone for something, you're saying, this is for higher classes only. This is for us, not them. It's the only conclusion that you come to if you think that we need to charge students money for school. Does that make sense? Because that vehicle has been corrupted. This is a vehicle for putting you into debt. A debt that can't be discharged, by the way, unless someone comes along and says, nah, forget it. You can't bankruptcy yourself out of student loans. If they come from a private source, you cannot discharge that debt through bankruptcy. I want you to be aware of this because some of you are going to be going to debt now, and you're going to have insurmountable debt by the time you graduate. And it doesn't matter if you've doubled your potential lifetime earnings, if half of it is gone to service that debt. Does that make sense? Now you can either fix that or you can just keep doing that to your children. I don't have kids. The line ends with me. I'm like pretty much the youngest person in my family. Like you have to go to like 5th cousins and some shit to find people younger than me. So whatever you want to do, that's cool. But I believe in you and I believe you can do better. You know what I mean? Oh, shit. Sorry about being so angry, but you overhear shit and just. Now, no one will want to listen to me because I don't have children. What do you know? But I'll tell you what I know. That means I can actually be objective about it because I don't have kids. I can actually provide an outside perspective. People with kids, too invested. You're biased. You cannot separate yourself from that. The fact that you're a parent. I can. Because I only have a dog. Dogs are so much easier. Like if I need to leave for a couple hours, I just give my 4-year-old a bone and like walk out the door. You can't do that with human 4-year-olds. I fucking tried it. People get all mad. No, they're gonna choke. How dumb is your 4-year-old that you can't just leave him with a chew toy? Jeez. Anyway. All right, I want to jump to problem number 6. I have x of theta is -2 cosine of 3 theta. So what's our amplitude in this case? 2. We take the absolute value of this coefficient. Don't worry about the negative. Amplitude is a distance. I just want the number part. That's what absolute value does. Just give me the number part. Don't worry about this plus and minus. And the period for this one, the default period is 360 degrees, but we're dividing by 3. So what's our period for this one? 120. And where are we going to start this? We have a cosine, but it's got a negative coefficient. So where's our start? At the bottom. Normally cosine starts at the top, but a negative coefficient means we're going to start at the bottom. So when I go to write, I'm going to put the bottom down here. This is my start. 1, 2, 3 points later, I will be at the mid. I'll make sure I can cut that in half easily. Then 1, 2, 3 points later, we'll be at the top. Then 1, 2, 3 points later, back at the middle. 1, 2, 3 points later, back at the bottom. And there's one cycle. Make sure we get the easily identifiable halfway point going up and down. And then those 4 spaces, those 5 points, making the 4 quadrants, but divided in 3. Now we'll get our halfway points that are going to be a third of the way off the middle. So a third of the way off the middle, and we'll halfway. Here's another middle, third of the way, third of the way horizontal, halfway up. Through the mids, we will draw essentially lines. And then we'll make sure it's flat at the bottom, at the valleys, and flat at the peak, and then just connect with a little bit of bend. So in this case, our period is 120. I'm going to mark in 0 and the 120. I want to cut it in a half, then a quarter, then a 3/4. So cut in half. Half of 120 is going to be at 60. Half of 60 is going to be at 30. 3/30 is going to put us at 90. Remember, 3/4 is just 3 times 1/4. Whatever the 1/4 is, it's just 3 times that. Now, in this case, the middle is at 0 as usual, but the bottom is at -2 and the top is at +2. So this point down here will be 0, -2. This point at the middle going up will be at 30, 0. The point at the top will be at 60, +2. The middle going down will be at 90, 0. And then the 120 happens at 120, -2. I know they look the same size, but that's because I was making the scale convenient for my drawing, not for comparison. If I was going to put these on the same scale, this second one would be shorter because our amplitude is 2 than the other one with an amplitude of 2. But I just want to practice dividing things up. Find your halfway points, and then horizontally between your named points, top, middle, bottom, middle, top. Make sure you divide that in thirds so you can easily locate your halfway points. Those are the ones we care about. Since sine of 0 is 0, we remember that because sine starts at the middle. That helps us remember that sine of 30 is equal to a half. That helps us remember that cosine of 30 is √3/2. Sine of 60 is √3/2. Cosine of 60 is a half. Helps us remember all these values. I'm sorry, okay? What do we think of this graph in vision? Here's the way we want to think about it. Here's the other thing that we want to think about. The amplitude changes and the period changes are all changes with multiplication. I changed the cosine of x with multiplication. I multiplied by -2, I multiplied by 3. In both cases, I stretched or squished the graph. I stretched it by 2 vertically, and I squished it by 3 horizontally. Multiplication produces stretching and shifting. Sorry, stretching and squishing. Multiplication produces stretches and squishes. A squish is just an anti-stretch. Multiplication by -1 produces a reflection. Here's the last thing for today. We got to decide if we're going to produce a horizontal change or a vertical change. We're going to list the things that happen to theta in this function. I'm going to list the order of the operations that happen to theta in this function. Now, I just said order of operations, but I don't mean PEMDAS. PEMDAS is trash. Parentheses aren't even an operation. It's just a grouping symbol. So let's think about the things that happen to theta. The first thing that this function says to do with theta is that we multiply by b. So I'm just going to abbreviate. I'm going to say we multiply by b. Once I took theta and multiplied by b, then I take the sine of the result. So I'm going to say as my second step, you do the sine of whatever happened. Once I've finished taking the sine of b theta, I multiply the result by a. And that ended up at y. So that's how we turn theta into y. This is the order of operations on theta. Start with theta, multiply by b first. Second, do the sine of theta. Third, multiply by a. Then you have y. That multiplication by b is an operation that took place before the trig function. So I'm reading this times b as this took place before the trig function. This multiplication by a took place after. So the two multiplications took place at different times. One was before the trig function was applied. One was after the trig function was applied. Here in the middle is when sine happens. So multiplication by b was before sine, then sine happened. Multiplication by a was after sine. So here's the big idea for today. Changes that take place before the trig function are going to be horizontal. Changes that take place before the trig function are going to be horizontal. Changes that take place after the trig function are going to be vertical. Before, horizontal, after, vertical. So the next thing that you want to think about, I want to use this kind of thinking, and I'm going to trade my operation of multiplication for an operation addition. I have two additions in this point. I've got an addition before the trig function and an addition after the trig function. I usually write my constant term first, but I put a plus d there and a plus c there. So the question here is, what does addition do? That's the question that we want to think about next. What does addition do? One of these is addition before the trig function, so some horizontal change. One of these is addition after the trig function, so some vertical change. The question is, what does addition do? Any questions on the question? Great, that's it for today. I'll see you on Thursday. Figure out what addition does, and we'll talk about it then. Have a good couple of days, and thanks for playing. Maybe I'll edit out my big old angry rant in the middle. That would require more effort than I think I'm willing to spend.